Okay, so previous lecture was about some representation of vector, then conversion from polar to Cartesian or Cartesian to polar, and find out the relationship in unit vector notation. Now, next topics is basically about lecture 2. So, lecture 2 was about vector product and scalar product. Okay, so first is scalar product. We consider the scalar product. Okay. So in case of scalar product, the result of scalar product of two vector is a scalar quantity, and in case of vector product, the result for big vector product is a vector quantity. Okay. So first thing, in case of scalar product, okay, in case of scalar product, scalar product, say we consider two vectors like that, vector A, and another vector B. Then if you consider the angle between these two vector, angle between these two vector is theta. Theta is the angle between these two vector. Okay. So say consider this is vector B, this is vector A. So A vector and B vector, these two vector produce angle theta. So this theta is the angle between A and B, not the angle produce a single vector with x-axis. Say we consider x-axis and y-axis. In this case, if we consider a single vector is given like that, this is a vector A, then the angle produced with positive axis we consider theta. So this theta and this theta are not same, because here coordinate system is involved, and we consider the angle produced a single vector with positive x-axis is theta. But here there is no coordinate involved here. Okay, just the angle between two vector A and B is theta. Okay, so then here you can draw coordinate system like that, then you can also find out the angle produced a vector A just like that. This is the angle produced with positive x-axis, and also this is the angle produced with vector B with positive axis. So this angle are different from the angle between these two vector. Okay, so in this case, just in case of scalar product and vector product, we have to consider the angle between two vector. Okay, in this case no coordinate is involved. Okay, so say two vector is given like that, vector A equal to 2y minus 3j plus k, and b vector is given like that, say vector B is equal to minus I plus 2j minus 3k. Okay, so these are the vectors, two vectors given, vector A and vector B. Now the thing is that these vectors are given in unit vector notation in I, J, K form. Okay, so if the question is given like that, first question number A, say this is number one question number A, find C such that C minus A is equal to minus B. Okay, so then from this equation you can easily find out the third vector C as like that, C equal to A minus B, Now if you put the values of A and B, so I say A vector and B vector, capital letter. Okay, so if the two vector is given, and if the relationship between with another vector is given, you can easily find out the remaining vector C. Okay, so this is first question. Now question number B is a question number B. Find the angle between vector A and B. Okay, angle between A and B. Find the angle between A and B. So in this case, if the question is given to find out the angle between two vector A and B, then you have to use the scalar product. So scalar product formula is A dot B is equal to A B sin theta. Sorry, cos theta. A B cos theta. For dot product, A B cos theta. So here A and B represent the magnitude of vector A and B, and theta represent the angle between vector A and B, and this is the scalar product or dot product A dot B. Okay, so from this you can easily find out the theta equal to cos inverse A dot B divided by AB, because we can easily find out the A dot B, because if vector A and B is given in unit vector notation, and from this we can also find out the magnitude A and B. Okay, so this is question number B, and say question number C is given component of vector A along the direction of B. Okay, or you can say find out the projection of vector A along the direction of B, or perpendicular component of A along the direction of vector B. বাংলা যেটাকে বলে লম্ব বিক্ষেপ, যেটাকে সেটা কি question number C. So this is one set question. Basically this is the question pattern. Okay, A B C, and I think in case of A, if the question is given like that, find out the magnitude of vector C. I think you can easily find out the magnitude, because if you solve this, the answer will be like that: C equal to say 3i minus 5j plus 4k. Then from this you can easily find out the magnitude of vector C. Okay, so this is the question pattern. Okay, now let's see how can we find out the angle between two vector and also component of a vector along the direction of another vector. Okay, so here the procedure is A dot B equal to AB cos theta. To find out the dot product A dot B, we have to calculate the unit vector dot product of unit vectors, because unit vectors are involved here. So let's find out the I dot I. So I dot I. So in case of similar unit vectors, if we apply this formula, magnitude of I, then cos theta. So what is the magnitude of I? So magnitude of I কত? Just একদিন বলো। For unit vector,
1, sir.
yes, 1. So 1 into 1, and the angle produced similar unit vector is 0, cos 0. So cos 0 is 1, and the answer is 1. So for dot product, yes, in question. Okay, so for similar unit vector, dot product result is 1. I dot I equal to 1, j dot j is 1, and also k dot k is 1. Okay, so this is for the dot product of two vectors. Now if we consider the different unit vectors, just like that, I dot j, in this case magnitude are 1 into 1, but the angle between I and j is 90 degree, because in three-dimensional coordinate system, if we consider x, y, and z, so these coordinates are perpendicular each other. So x produce 90-degree angle with y, and also uh, z produce 90-degree angle with x, and also z produce 90-degree angle with y. So that's why the angle between I and j is 90 degrees. So that's why the answer cos 90 degrees is 0. So if we consider different unit vectors, so the dot product result is 0. So I dot k is 0, and also j dot k is 0. Okay. So this is the main result for dot product of unit vectors. Now let's solve a dot b. How can we find out the a dot b? A dot b. So a dot b is equal to say given value is 2i minus 3j plus k dot minus i plus 2j minus 3k. Okay, 3k. So here I think this is uh, three quantity. If we multiply three quantity with three quantity, then result will be as 9 quantity. But here we know that I dot j is 0, I dot k is also 0. So no need to calculate 9 quantity. Just if we multiply this with this, this with this, and this with this, then the result like that. 2 with multiply minus 1 will be minus 1, because I dot I is 1. Okay, minus 3 into 2 is minus 6, and plus minus is minus, plus into minus is minus, so 3 minus 3, and result is minus 11. Okay, so this is the dot product of a dot b. Okay, so here unit vectors, basically I dot I is 1, so no need to write down unit vector I j k here. Okay, so basically this is scalar quantity. The dot product of two vector is a scalar quantity. Okay, so if you write down I j k here, then the result is incorrect. Okay, okay, so this is the procedure to find out the dot product of two vector, and the magnitude, in case of magnitude of vector, a equal to root over 2 square plus minus 3 square plus 1 square, which is equal to root over 14, and the magnitude of vector b is equal to root over minus 1 square plus 2 square plus minus 3 square. Okay, then this is equal to also same answer is root over 14. Okay, now from this equation we can easily find out the angle between these two vectors. So theta equal to cos inverse a dot b divided by magnitude of this two vector a b equal to cos inverse minus 11 root over 14 multiplied by root over 40. Okay, so if you use the calculator, then there will be angle. Let's say particular angle, the angle is in degree. So this is the procedure to find out the angle between two vector. If the question is given to find out the angle between two vector, you can follow this procedure. Okay, so this is the procedure to find out the angle between two vector. Now in case of question number C, the component of a vector along the direction of another vector. So if we draw a vector like that, this is vector A and this is vector B. Now if the angle is given theta, now if we draw a perpendicular line from the first vector head to second vector, then this part will be equal to A cos theta. A cos theta. So this A cos theta is called the component of vector A along the direction of vector B. and also called the projection of vector A along the direction of vector B, or you can say the perpendicular component of vector A along the direction of vector B. So if we apply the dot product formula, then A from this equation, we can say A cos theta will be equal to A dot B, A dot B divided by B. Okay, so if the vectors are given, vector A and B are given in unit vector notation in IJ form, then you can easily find out the projection of vector A along the direction of vector B by using this formula. Or if the angle is given, angle between these two vectors, and the vectors are given in unit vector notation, then you can also use this formula A cos theta. Okay, but this theta is the angle between A and B. Okay, this theta is the angle between A and B. So if the angle is not given, then you can use this formula. If the angle is given, you can use this formula. Okay, so both are equal. Okay, so this is the procedure to find out the component of a vector along the direction of another vector. Okay, so now do you have any question regarding this scalar product?
No, sir.
Okay, so now let's talk about the dot product, cross product. Okay, so cross product. So in case of cross product, the angle is remains same. We consider angle is same. The angle between two vectors theta, and this is vector A, this is vector B. Okay, so A B. Now cross product formula is A cross B equal to magnitude of vector A, magnitude of vector B, sin theta. And another thing is here, the cross product of two vector result is a vector quantity. So that's why we have to introduce a new vector, unit vector, n cap, which is basically represent the direction of the result of these two vectors. So if we apply the right hand rule, if we move to A to B, then this term represent the direction of the resultant new vector. Okay, so in the direction of n basically. Okay, so if you go to just along that direction from A to B, then the basically direction will be downward. If we move B to A, then the cross product will be A B cross A, and the new unit vector will be upward, basically perpendicular to the plane of AB. Okay, so this is the direction of the unit vector. And if we try to find out the magnitude of A cross B, A cross B, A cross B, then the magnitude of A cross B will be AB, AB sin theta. Okay, so this is the formula. Now let's find out the cross product of unit vectors. So A cross B is equal to 1 into 1 into sine 0 degree, because the formula is sine theta. AB sine theta, magnitude of two vectors is multiplied by sine theta. So sine 0 degree is 0. Okay, so there is a unit vector here, so no need to write down the unit vector. Because multiplication of 0 with any part, anything is 0. Okay, so I cross I equal to 0 is equal to J cross J is equal to K cross K. So for similar unit vectors, the cross product result is 0. Now if you consider different unit vector I cross J, so in this case 1 cross 1 cross sine 90 degree, and we have to introduce a new unit vector because the result of two cross product of two vector is a vector quantity. So the perpendicular, basically perpendicular to this plane IJ plane is the remaining unit vector K. Okay, and in this case you have to find out, just apply the right hand rule. So like that, So here, this is, if you consider this is x, this is y, this is z. So unit vector I, j, and k. If you move I to j, so just like that, I to j. So upward direction represent the remaining unit vector k. Okay, so the answer is k. But if you move different direction, say j cross I equal to 1 into 1 into sine 90 degree, but the unit vector will be minus k, because just opposite direction, so just like that. Okay, so downward direction, basically downward, so that's why this is minus k. So the answer is minus k. So in this case, you can follow a cycle like that: I, then j, then k, then I. So if you go to just like that, I, j, k, I, so I cross j equal to k, j cross k equal to I, and k cross I equal to j. But if you move opposite direction, I cross k equal to minus j, k cross j equal to minus I, and j cross I equal to minus k. So this is the procedure for cross product of two vectors, two unit vectors. Okay, so for similar unit vectors, cross product is 0, and for different unit vectors, cross product gives the remaining unit vector, and you have to find out the sign also. Okay, so this is the procedure. The next thing is that how can we calculate a cross b? Okay, so a cross b, in case of a cross b, you have to follow the matrix rule. A cross b is a cross b equal to I, j, k, and the coefficient x, ay, az, and bx, by, bz. Okay, so you can follow this rule, or you can follow also same rule, just normal mathematical rule like that. A cross b is equal to just axi plus ayj plus azk. Okay, cross bxi plus byj plus bz. Okay, so this is normal mathematical rule. So from this you can find out the 9 quantities, but in case of I cross I, result is 0. So you have to calculate the remaining two, this part and this part. Okay, so ax by and I cross j is k, so ax by k, and ax bz, so I cross k, so I cross k is minus j. Okay, so that's minus j or j, yes, minus j. So in this case, minus ax bz. So this is the normal mathematical rule, but if we apply this rule, you can easily find out the result. So in case of I, this part close, so multiplication of these two is ay bz, and multiplication of this diagonal line, so minus az by. Okay, similarly in case of j, there is a minus sign, minus j, so this part is close. Multiplication of ax bz, ax bz, minus multiplication of these two az bx. In case of k plus k, this part is close, so multiplication of these two is ax by minus multiplication of these two ay bx. Okay, so this is the procedure to find out the cross product of two vectors. So you can follow this rule, this rule, also this rule. Okay, So this is the procedure to find out the A cross B, and you can also find out the magnitude A B, okay, by using the Pythagoras formula root over a x square plus y square plus z square. Okay, so this is the main thing for cross product. And another thing is that if the question is given parallel component of a vector, parallel component of a vector along the direction along the b vector, along the b vector. So the basically parallel component is like that. Okay, this is vector A, vector B. Okay, so this is the theta. Now in previous case, in scalar product, we draw a perpendicular line. This is perpendicular line. This is a cos theta. Okay, a cos theta, which is called the projection of A along the direction of B, or component of A along the direction of B. Now, if the question is given parallel component of A vector along the direction of B, the result will be like that: A sin theta. Okay, so A sin theta basically it comes from just like that. If we draw a parallel line to this vector B, then this part is A sin theta. Okay, A sin theta. That's why this is called the parallel component of vector A along the direction of vector B. So this is A sin theta. So if the question is given the parallel component of vector A along the direction of B, then this is the result. Okay. So similarly, if the question is given the component of vector B along the direction of vector A, then the B sin theta, component of vector B along the direction of vector A, basically not component, parallel component. And if the question is given component of vector B along the direction of vector A, result will be B cos theta. B cos theta. So this is the topics covered in lecture 2, part 1 and part 2. And in third part, basically the discussion was about some application of vectors, so which is basically not important for your final and midterm exam. These topics are included for your ideas about the application of vectors in some mathematics. Okay.
Okay, sir.
Okay, now do we have any question regarding lecture 1 and 2? I think you completed the lectures. Okay.